Welcome everybody. In this episode we're gonna create this game where you can drive a car over terrain and pick up coins. It's an excellent starting point for creating your own car game. So let's get started. Let's start by creating an empty project, a 3D or P project, and call it Drive. This is going to be a third-person game, so it's always a good idea to add the third-person starter assets. So let's do that. We can use the demo scene that's located in this folder. Let's move it to over here. And open it. We still need to convert the material to URP. So over here we can select all materials and then convert them. Okay, it's working, but it doesn't look anything like a car game yet. Let's start by deleting the scene except for the player and the cameras. So everything that's under environment can be deleted, and some lights as well. Now we still need a base floor, so let's for now just create a cube and extend it in the X and Z axis. Okay, let's create a ground texture onto this cube so we have a real floor. I found this texture that you can download for free, and I'm gonna add it to the project. I created a folder called environment, and I'm gonna drag in this picture and create a material. I'm gonna call this material ground, and now let's add the base map and use the material on the cube. You'll notice that this is quite big, so we need to tile this. Okay, this will do for now. So now we're going to replace the robot with a 3D model of a car. You can go to the asset store and download a free asset, or you can download a free 3D model from another site, but I chose to use this car. So I'm gonna download and import it. got a prefab over here, and we can replace the robot. First we need to unpack the prefab, and then we can remove this part. And again we need to convert some materials to UOP. Okay, cool, so now we got a car. Let's see what happens if we run the game. Okay, the car is actually already moving, but not that fast, and there are a lot of other issues we need to fix. So first, let's start with changing the speed of the car. It's now way too slow. Can make it 10 times as fast. Okay, that's better. So, and now to make this car more interesting, we can add a few lights. We can add headlights and tail lights. So let's do that now. We should add them over here. So go to this object and we can add point lights. The tail lights are going to be red. And we're also going to add spotlights for the headlights because they need to shine. Okay, so we've added 4 point lights, 2 for the headlights and 2 for the tail lights, and also 2 spotlights with an intensity of 200 and a range of 500. You can widen the angle of the beam like this, so I think this is just fine. Okay, so with these lights the car looks much cooler, but you will notice that the wheels are not spinning when the car is driving. So that's the next thing we're gonna fix. I'm gonna write a script for that. So I'm gonna create a folder called scripts. And I'm gonna add my first script. I'm gonna call it car because it contains the behavior of the car. Because this car has 4 separate wheels, we can rotate these meshes and it will look like the wheel is spinning. I already have the code for that over here. So we take a reference to all the 4 meshes that we're going to use. We're also going to take a reference to the third person controller, and in this third person controller we're going to have a value for the speed that we can read and that we're going to use to rotate the wheels. So when I save this, we're also gonna create this speed value. So when we go to the starter assets, third person controller, scripts, and we open the third person controller script, you see this internal variable speed. We can expose it like this, and now we can use it inside our car script like this. Because we use the update and not the fixed update, you always need to put in delta time, because the frame rate can differ on different machines and you want the rotation to be the same independent of the frame rate. Okay, so this is the actual code that's rotating the wheels, and we can now attach that to this object. We go to car script and drag it onto the object. Now we also need to set the reference for the 4 wheels, so we drag them in as well. And after that, let's run our application, and you see that now the wheels are spinning as soon as the car is driving. The next step is going to be to add a terrain to drive on instead of this single square. So we're going to install the terrain editor. Terrain tools, it's already installed, so then I can find it over here, and I'm gonna open the terrain toolbox. I'm gonna park it over here. Let's create a terrain of 1000 meters and square meters, and yeah, let's use a starting position of -500 for the X and Z axis, and that way the 0 will be exactly in the center. I find that to be useful. So now I press create, and we have our terrain over here. So we can now remove the cube, and we have an empty terrain. Now we can sculpt this to create some hills. So go to the inspector and raise and lower the terrain. We're also going to add texture onto this terrain. Therefore we need to create a layer. Let's call it ground. And we can use the texture that we had before. You notice that the this texture is quite small. We can enhance it by setting the tile size. So now we got this terrain and we can already drive onto the hills. Okay, so I've added some hills and some trees from a package, and also a skybox for the sky. So now let's set the skybox. And also add the trees. So I've added the trees over here. And I can use this to quickly create multiple trees. Okay, this looks better. Now we have a real environment, but still we have a few problems. If you face this direction, I press the up key, I will go in that direction. When I press the down key, I go in the opposite direction. When I change the camera, I also change the direction the car is moving to. That's not what we want. We don't want to steer the camera by moving, steer the car by moving the camera, but we want to steer the car by using the A and D keys. So instead of turning and moving into the camera direction, W should increase the speed. D should no longer turn and move to the left, but should just turn the car itself to the left. And S should decrease the speed or put it in reverse. And A should turn the car to the right, or actually to the left, and this one to the right. Alright, so let's create code for that. We add also the brake light, because I want to switch off and on the brake light when I hit the brakes. Then I put in some variables like the maximum forward speed and reverse speed, how fast you steer the car, how fast we're accelerating, and how fast we're slowing down when we're no longer pressing the W button, the gas. And also the brake strength. I've also added this variable, the current car orientation, because we need to store the current car orientation. And then I've changed the move function to this, so we can remove the old move function. Because this is no longer suitable for our purposes. Let's delete that. And let's take a look at the new move function. So the transform rotation is the one that is stored, and we rotate the car if we press the A or D key, which will set the input move X value. Then we also use that steering power. We use time delta time because this move function is going to be in the update. But we've also created a new function, update car speed, and that one will not take into account this delta time, so it should be put in the fixed update. So let's take a look at that update car speed function then. We can still use the sprint button if we want, and then we can increase the acceleration by a factor of 2. To accelerate, we look at the value of move Y, which is the W and S keys. If the W key is pressed, this value will be greater than 0 and we will accelerate. There will be a maximum speed, so we will cap to the maximum speed. And when you put it in reverse, that means the S key, then we enable the brake light, otherwise we disable it. And if the car has no speed, has a speed, then we will use the brake factor, otherwise we will go into reverse. This is the part to go into reverse. And when you don't press either the W or the S key and the car still has speed, it will slow down. That's simply done by using this multiply factor, which is smaller than 1, so it will slowly turn to 0. Alright, that's it. So let's save that and let's take a look. Actually, you don't see anything different on the screen, but when I press the controls, I can steer left and right. Because we added properties to the third-person controller script, we need to locate it into our scene and set it to the proper light. Now you can see that as soon as we hit the brake or the S key, the lights will turn on, the brake lights, and the car will move. It will move left and right, but only when the car is moving. It will be able to turn, and it will turn. You can make circles like this. You couldn't do that before with the W, A, S, and D keys. So this is really a really suitable way to control a car. The next thing that's not correct now is that the car is moving straight while the terrain is not always flat. So if you take, for example, this point, let's move to the car. You see that these tires are actually not hitting the ground. So we should fix that by rotating the car. Fortunately, we can measure the terrain height. We can do that at all 4 the wheels. So if we measure the terrain height, we take first the left and the right side of the car. We take the highest point of the terrain on each of these wheels and the highest point of terrain on each of these wheels. Now it's pretty the same, so it doesn't really matter, and then we move this wheel until it hits the ground, and this angle between this wheel and the old position of the wheel. Another problem is that another thing that we need to fix is that if you run over the terrain, the car stays stable. Another problem that we need to resolve is that if you drive the car over the terrain, it is pointed only in one direction and it doesn't move with the terrain. So for example, if we are here and we take a look at the car, you will see that it's always straight, while in reality it should be tilted, just like this. Or like this actually. So to make that happen, I made a picture for you. Look, we can use of course the physics engine to fix this, but the best thing to do is to measure the height of the terrain at all 4 wheels. So at this wheel, this wheel, this wheel, and this wheel, and then if we measure the 2 wheels on the left side, we take the terrain point that is the highest of the 2 of the wheels, because the car will rest on the highest point, and we do the same for the 2 wheels on the right side. And then we take those 2 wheels, so one has the terrain over here and the other one has the terrain over here, so we have this difference in height from the left to the right side. We also know the length of the distance between the wheels, so with these 2 values we can calculate the angle over here. That's the tangent of these 2 vectors, and so this angle we need to tilt the car by, and then of course after that we need to do the same for the tilt in the z direction. So this tilt we need to fix as well, and that's actually analog to the way that you do it for the left and right side. So putting that in code, it looks like this. So putting this in code, it looks like this. We got this method rotate with terrain. We measure the height of all 4 wheels, and we take the difference of the highest of the left and right side, and then we take the tangent of the angle of that with the distance between the 2 wheels, and we do the same for the front and the back, and finally we rotate transform the car on the x and the z axis. We're going to call this function the move method after we moved the car, and in the third-person controller script we need to set the references to the wheels. Okay, let's test it. Yes, the car is actually moving along with the terrain. So it's tilting to the left and right and forward and backwards when we drive over a hill. You see it's a bit shaky. If you want to prevent that, you could store this angle and change it a little bit each time. So for example, store this value, and then the second time, if you have a new value and it's higher, then don't just use that value, but increase the old value a little bit until it finally gets to that new value. And that way the effect is that the car will move more smoothly and will a little bit have a delay. It's more natural probably, but for now I'll leave it like this. The next thing that I want to change is the camera. You can see that the camera is following the car right now, but it's not moving behind the car. So if we drive like this, we can't see what's happening in front of us. So as soon as you start driving, you actually want the camera to turn and to face this direction. So you drive around like this, and you can see what's happening in the direction you're driving to. So let's just have another look at the car and see what I mean. So I want the camera to be somewhere over here. So we have this player camera root object already created. The root is over here at the moment, but I think it should be somewhere over here. So that's the position of the camera when we're driving forward. But I also still want to be able to use the mouse to look around, so that we don't need to drive in a specific direction to see what's happening in that direction. We can use the mouse to look around like this, and then as soon as we start to drive, the camera will move to the position behind the car. So we actually have two modes. One mode is to look around if we use the mouse, and one mode is to stay behind the car as soon as we use the W key to move the car forward. To realize that, we're going to remove this camera rotation function. We're using the late update method to process the camera, because first we want to update our position of our car, and finally we want to update the position of the camera, so the car will not move anymore, and then we can create a stable position for the camera. So I still need to create a few variables and functions, so let's do that now. Okay, these are the variables we were going to use for the camera. We have that camera root that I showed you already. We also have a camera look at point that we still need to define. So let's do that now. We will look at somewhere of the center of the car for now. You can change that a little bit to give it a little bit of a different view. So then we have the player follow camera that is actually this one. we have a camera distance. That's the distance when we look around. We can look around the car and we have a certain distance that the car is at. So for example this, and if you want to look from more far away, you can do it like this. But I prefer to have a fixed distance so that if we look around we will always have the car the same size. Okay, and so we have the camera rotation angle that's used for the look around of the mouse. We store that position, and we have the look around ratio and a look around position. So in this late update function we first check for mouse input. If the mouse is moving to the left or right, we change the look around ratio, we increase it until it becomes the maximum value of 1. Then we are just looking around. If we're not moving the mouse, then we check if we're accelerating by pressing the W key. If that is the case, then we decrease the look around ratio. We update the look around position based on the value of the mouse X value, and we store the look around position. And then in this part we have a lerp, a linear interpolate between the camera root position, which is the position over here just behind the car, and that look around position that is somewhere on this circle. And yeah, when we're looking around, the ratio will be 1 and this value will be used. If we are completely not looking around but accelerating all the time, then finally we will only use this position and the camera will be behind the car always. We use this lerp to make a smooth transition from one position of the camera to the other. Okay, I've also added a debug log here so you can see the ratio when we demonstrate it. We also need to remove the follow object of the camera because we now move the camera manually, and then you can press play and you will see that the camera stays behind the car all the time, and as soon as we start moving the mouse we see the camera rotation. And as soon as we accelerate again, the camera moves behind the car again, slowly. So you observe the value of the look at ratio here at the bottom. So now we're only looking around, and then if we accelerate slowly, this value goes to 0 and we are only using the position from behind the car. So this works quite well. Okay, let's add one small detail over here. I see that this license plate is empty. It's very tempting to put our name in there, so let's do that now. I've downloaded this FBX file of a Bitcoin for free. So let's drag this Bitcoin into the scene. We're gonna extract the materials from it. We need to scale it a little bit because it's too small at the moment. We're also gonna change the material. Let's make it a yellow coin. And let's make it metallic. Okay, cool. So when we're done, we can actually, I think we don't need this. So let's just unpack this prefab, remove this, and we can stick with only this part. We drag it into here and create a prefab out of it. Let's call it PF Bitcoin. Now we can use this to create some items that we can run over and collect with the car. I've downloaded and installed this free effect package. It's over here. It contains some prefabs, and we will use that to show an effect as soon as we pick up one of the coins. So it looks like that. It's now a bit too small, so I'm gonna change it a little bit. Let's make it 10 times bigger. We need to change some values here as well. So I think this should also be 10 times bigger. Okay, let's see how this works out. Okay, that's better. So, and now we go to our prefab for the coin, and I'm gonna add a script to it. Let's lock it. So this part of the screen will stay. Now we can move to the script and drag this coin script into it. This coin script needs an effect variable. That's the prefab that we just edited. So we're gonna drag this in, and I'm going to show you the coin script. It's very easy. Actually, this shouldn't be there. So it's just on update, we rotate the coin on the Z-axis, and as soon as we have an on trigger enter, that's when something collides with the coin. Then we show that effect that you just saw, and we also gonna destroy this object, the coin, because the coin needs to be removed from the screen after it's been picked up. So let's see how that looks like at the moment. Go to the prefab and drag one into the screen, and run the game. Okay, so the coin is moving, it looks quite nice. We also see the effect over there that we dragged in, but we can remove that now because it will instantiate by a script if you run over this Bitcoin. And the next thing we need to do is to actually not drag them in manually, but we create a spawn script for that. And we can create a folder over here, script, and there we can just add scripts to that we use in our scene, and that will be the spawn script, the coin spawn script. I'll drag that one over here. So we can see the coin spawner. I will open it. What this will do is create 200 coins. It will take a random spawn position anywhere from -500 to 500 on the X and Z axis, because our terrain is, if you remember, from -500 to 500. You can see that if I move the car over this screen, the end is about 500. So the Y position we don't know yet. We take first the value of 1000, so we put it somewhere in the sky, and then we measure the terrain height at that point, and we put the coin a little bit higher, but then the coin will stick to the terrain, and because the terrain is not flat, we need to take that into account, and we use this function for that. And then we instantiate the coin at that position. We rotate it a little bit over here because it's not rotated properly by default. So, and that's it for the spawn script. To use the spawn script, we also need to set the prefab, so like this. We're also gonna add a small script to this effect so that it will be destroyed after a few seconds, so it doesn't run forever. I got the script over here. It's called delete after delay, and we set the delay to 3. The script is very simple. We just check for the time, and if the time has passed the 3 seconds, we're gonna destroy the object. One final thing we need to do is to add colliders to both the car and the coin. So for the coin, we can add a mesh collider, make it convex, and make it a trigger, because we want to use the on trigger enter function, this one. And for the car, we can just add a box collider. Okay, so this will be just fine. Before we're gonna test it, we're gonna put the camera root a little bit to the back, and we're gonna slow down the maximum speed so we can observe what's happening when we pick up a coin. You see that the coins get picked up, and the effect is also showing. so it works. So that concludes our game, and as usual you can download the complete project from GitHub, and see you in the next one.